Thank you for the introduction and good afternoon to everybody. It's my pleasure to be here to present this work, which is basically related to the cyber risk assessment of power grid control systems. And so it moves actually the focus from pure network analysis to an application sector, which is in fact power grids and power control systems. And I'm just going quickly in introducing the research context where this activity is going to be performed, and then I will give you the main key points of our testbeds architecture and the experiments we are doing on these testbeds in order to provide some sample results from selected experiments. Basically, RSE stands for Research on the Electroenergetics System and is a publicly owned research company in Milan, Italy. And it's carrying on research activities on the whole electroenergetic sector, which is distributed over 4 technical departments, and in particular the cybersecurity of power control system is performed within the power system development department of our company. Basically, the focus, as I said, is on the evaluation of the assessment of cyber power risks, and this basically is due to the need of taking into real consideration the critical communication and control system which are used and deployed in power grid operation and control. And in particular, all of us, I think, know that cyber threats are increasing in these last years, due basically to the use, the huge deployment, even in these critical sectors, of standards, components, and protocols. So basically, our activities is just to support the protection of this kind of critical infrastructure, to perform sample attack experiments which are able to produce inputs that may be used for evaluating, for calculating cyber power risk index. And in the paper you can find in the proceeding, we have basically addressed both accidental and malicious attacks processes. And this kind of activity is perfectly in line with what is required by the European Commission. Actually, I don't know if you already know, but maybe not, because it's a sector specific, or basically it's specific for critical infrastructures. There has been in 2008 a directive from the European Commission requiring the protection of critical infrastructures and basically requiring the operators of these infrastructures to develop and to support an operator security plan, and in particular also considering the information infrastructures. There has been a following communication from the European Commission requiring to enhance and to be prepared for the security and resilience of large scale cyber attacks and disruptions. And in the Italian context, in May 2011, we have also a recent legislative decree which basically applies the directive to the Italian member state. And so this kind of activity actually involves different kind of technical aspects, and in particular I've listed here real-time systems, substation automation, SCADA, which are supervisory control and data acquisition systems. But what I'm going to focus on is on the communication requirements and the cyber attacks by using test beds. And in particular, this means basically in terms of power system security, to extend the model, the security model of the power system in order to analyze both power contingencies and ICT threats together. And the focus is, as I said, on the concepts of attacks, which basically includes or realize specific types of threats, exploiting vulnerabilities which are in place in the control architectures. And by analyzing the effects of these attacks on the ICT assets, we may also analyze the impact of the ICT failures on the power service, actually. And here is a picture of the laboratory where we are doing the experiments, and in particular, this kind of activity requires to develop control applications which perform normal and emergency operations for the power grids by using standard communications which make use of standard application protocols and also transport and, of course, network layer protocols. And in particular, we have also included the security measures in the ICT infrastructures and developed attack scenarios, which are of different types. Basically, we have till now developed the flooding-based DOS attacks and complex intrusion as well. And sorry. And this kind of experiments, as I said, may provide inputs or have provided inputs which are then included in the cyber power risk index. Basically, the power grid control is a very complex infrastructure, basically combining the electrical infrastructure with the ICT infrastructure, and in particular, the ICT infrastructure is in turn divided into different kinds of sites which are centralized. DSO stands for distribution system operator, the power distribution system operator, and the transmission system operator centers and substations. And this infrastructure basically performed different kind of control functions at the center level and the substation level, both at the DSO and TSO domains. This kind of reference architecture is then realized and deployed in our testbeds, and in particular we have a set of basically different kind of sites which are implemented through virtual LANs on switch Ethernet network and interconnecting the substation automation networks, control center networks, and also ICT management networks, and including, as I said, the technical security measures in order to perform the experiments on the critical assets. The experiments are selected by performing a topological analysis of the testbeds platform and architecture, and what is interesting is to define a specific attack model which basically generalizes different kind of possible scenarios, attack scenarios to be experimented on the testbeds, and in particular an attack process is a logical sequence of intrusive steps along a given compromise path. And we have identified a generic model composed of 5 intrusion steps, which is able to summarize different kinds of attacks on the testbeds. And the role of these experiments, as I said, is basically to support the probabilistic interpretation of the different factors involved in the cyber power risk index, which are vulnerability existence, threat occurrence, and attack successfulness. So what is interesting in the experimental activities is the analysis of the application logs which may be collected during experiments by using a specific kind of tool which are related as I said, to specific application protocols. And here is the interface of our analysis tool, which is able to produce a set of performance measures of the application level communications. And here you see the different kind of measures: inter-message time, inter-connection time, time to failure, number of lost messages, and so on. And so what we have tested is the effect of this kind of different kind of attacks on the information exchange by an emergency control procedure from the Italian grid code. This is particular critical application, and the analysis of its impact is very relevant in terms of the risk contribution, the percentage of contribution to the global risks. And in particular, here is the control scheme of these applications, which is basically aimed to perform automatic load shedding of medium voltage loads on the power grids, is based on an application protocol, domain specific, which is TCP based for doing a specific arming request. And it is also based on multicast UDP for sending trip commands to substation from the TSO to the DSO substation, actually, so in order to achieve the quick response requirements of this kind of trip commands. What we have performed are, as I said, different kind of attacks, which are both physical anomalies and malicious attacks, and in particular I will skip the physical anomalies, but moving to the flooding-based attacks, we have basically modeled the attacks by using a template which is able to describe or to list the parameters of the attack we are doing to perform, and the characteristics of the architecture we are using for the experiments in terms of security measures used, and the communication protocols and the parameters of the application layer protocol and the metrics that we would like to measure. So the effects of these flooding-based DOS attacks may be shown by for instance, by the graphics showing the different measures I spoke before, and in particular, here you see the delay, the effects in terms of delays to the inter-message time of one sample experiments, and in particular, here we can see the comparisons or the sensitivity of the effect by using different payload sites for the malicious traffic. And so we can see that, of course, the number of lost messages changes and increases by using a payload which is actually the same payload of the regular traffic of the application. And the same here, we can see the differences by using different sites payload to the inter-message time measures and to the percentage of lost messages. And basically this kind of effect and unwanted effects may be mitigated by using intrusion prevention capabilities which are available on the Cisco routers, actually, which are the targets of our attacks. And here we can see that the effect basically is solved or eliminated by configuring in a suitable way the intrusion prevention system which is available on our architecture. The experiments, I mentioned the fact that we also experimented more complex attacks which are basically has a higher impact in terms of the electric power service, which are able to provoke the arbitrary trip of a high to medium voltage substation, about 300 substation actually, by developing basically much more complex intrusion processes, which are basically based on the execution of a malware code, which is able to interfere with the application communications in order to provoke the unauthorized trip of the substation. This has another kind of, I will move quickly to the effect of this kind of attack, and we will see that in terms quantitatively, the effect is much less higher with respect to the DOS. In fact, we have just the loss of a couple of packets during the intrusion, but anyway, this is the first warning to the operator or to the person which is which is in charge of security of this kind of application. And by going to a deep analysis on the traffic and on the tracks, it is possible to, during the loss of these packets, we can see that there is actually an intrusion by an unauthorized entity. And so to conclude, this kind of activity basically it's exploit a testbed for power grid control in order to develop repeatable tests which may be used for measures in the effects and for protecting, for defining the useful protection and measures for protecting the infrastructures. So I think that there are a set of specific best practices which may be derived from each experiment, but just to give you an example, by looking at the flooding-based DOS processes, we may derive the fact that the effectiveness of this kind of attacks depends on the actual attack rate generated by a certain number of attack nodes. It depends on the bandwidth consumption caused by this malicious traffic, depends on the capability of managing congestion, of course, of the network used, and on the level of overloading of the communication resources of the attack targets, and also on the cumulative effect of repeated attacks to unrestarted targets. So there are a lot of parameters which change the effect of the attack depending on the architecture of the infrastructure, basically. So just to go quickly to the conclusions, we may say that this kind of results feed the calculation of the cyber power risk index, and the analysis tools also may be used for increase the security capabilities of the operation of the power grid.